All right. So if you will, go ahead and pull out. Oh, you gave me the wrong one? Okay. Pull out the right triangle trigonometry notes we were looking at on Friday. I'll pull that up in just a second. Now, if you were absent, I can go ahead and get you a copy, but if you were here on Friday and you've just misplaced it, you'll need to go ahead and maybe take out a sheet of paper, spiral, wherever you want to go ahead and copy those notes. Because remember, I'm only going to have enough, for everybody to have one. Let me go ahead and make sure. It's going to be an interesting recording. Make sure I erased all this. Okay, I did erase it all. Okay, so we're good. Okay, cool. People at home right now are just looking at a blank screen. Don't know what's going on. Okay, so let's sign her. Okay, so on Friday, we started right triangle trigonometry, and we started to expand off of SOHCAHTOA, what you learned back in geometry. Okay, so what were those three main trig functions? Okay, James, what you got? Sine, cosine, and tangent. Okay, so let's go around the room pretty quickly. Okay, so I said all right. Okay, what is sine's ratio? Its definition. What two side lengths do I need? Sine of theta is what? Opposite over the hypotenuse. Good. Let's see. Ashley, what about cosine of theta? Adjacent over the hypotenuse. Very good. And Vanessa, what about tangent? Opposite over adjacent. Okay, so that's SOHCAHTOA. And then after that, we started talking about the fact that each of these trig functions have a reciprocal trig function. May, can you tell me what's the reciprocal of sine? Well, true, but what's the name of the function? Starts with a C. What's that? No, James? Cosecant. Okay, so sine and cosecant are going to be reciprocals. Okay, Mason, what about the reciprocal of cosine? Secant. Cosine and secant are going to be reciprocals. And Rami, what about tangent? What's its reciprocal? True, but what's the trig function? Tangent is reciprocal of? Starts with a C? Cotangent. There we go. Fantastic. Okay. So here are our trig functions that we were looking at. So remember, these you want to be as familiar with them as possible. You need to know not only which pairs are reciprocals, but also the ratios for each one. You've got to have those because we're building off this to get to bigger concepts. Okay, and then on Friday, we took a look at evaluating our first with a special right triangle, 45, 45, 90. So the relationship here was x root 2, x and x because it's an isosceles. So according to these definitions, we just plugged in the appropriate values. Everybody seemed to be doing okay. And then this is what I asked you to do over the weekend. Our second special right triangle, okay, 30, 60, 90, the side relationship is going to be x root of 3, and 2x. So I asked you to go ahead and evaluate all 6 of those trig functions at 30 degrees. Okay. So did anybody have any questions on any of those? Or did anybody want to look through? Yes, sir. Let's look at secant. Okay, so secant. It says we want the hypotenuse length over the adjacent. So I'm looking at my figure over here. The hypotenuse length is 2. Okay, so I'm going to go ahead and put the 2 over. What's the adjacent length according to this figure? Square root of 3. Now, that doesn't look like 2 square root of 3 over 3. What did I do to it? Okay, does anybody remember the term we used to rewrite it? It starts with R. We're going to rationalize it. That's exactly right. So we don't like having a radical in the denominator. So we're going to multiply this by a version of 1. So because it's the square root of 3, I'm going to multiply the numerator and denominator by the square root of 3. So up top, that product would just be 2 root 3. And here's the thing. A square root of 3 times square root of 3 would give me the square root of 9. That's what we want. We want to create a perfect square so that we can remove the radical. So see, that's where I ended up with 2 root 3 over 3. Okay. Sir, is that good? Okay. Good, good, good. Any other questions about this? How many people got all 6 of those right? Fantastic. A lot of hands going up. I like to see that. Good, good, good. Okay. Now, what we're going to go ahead and do for the next section, we evaluated all of these at 30 degrees. Now we're going to do this at 60 degrees. So it's still a 30, 60, 90 triangle with the same lengths, but now we're focused on 60 degrees, no longer 30. Okay. And we'll go ahead and run through a couple of these. Like, for example, let's take a look at sine of 60. Again, it doesn't matter what the angle is. Sine is always the opposite over the hypotenuse length. So I'm looking at my figure here. Again, it's just the triangle that we just saw kind of oriented in a different fashion. What's the opposite length? Square root of 3. And what's the hypotenuse length? 2. So if I come on over here, that's why we have square root of 3 over 2. Let's go ahead and do another one of these. Let's say cotangent of 60. So it says adjacent over opposite. So what would that be according to this figure? 1 over the square root of 3. But just like before, we would have to what? What's that word again? Starts with an R? Rationalize it. So can anybody help me out? What would I get if I rationalized 1 over root 3? Go. Fantastic. Okay, is everybody starting to get the idea? Did anybody want to try one of the remaining 4, or did anybody want me to go ahead and show what the remaining 4 were going to look like? No? Okay. Then, let me go ahead and get this set back up. And here we go. We are on number 4. We're trucking along. Okay, let theta be an acute angle such that sine of theta is equal to 5/6. So given one trig function, we want to go ahead and find the remaining 5. So we know that sine of theta is 5/6. We just have no idea what theta is. Okay. Now here's the thing. Before we even start this problem, because I already know sine, what's the one trig function I immediately know? I don't have to do any work. Why cosecant? Because they're reciprocals. So if sine is 5/6, then that means cosecant has got to be 6/5. Okay. Now, unfortunately, I can't just immediately go ahead and get the remaining ones. That's where my figure is going to come in. All right, so I can put theta wherever I'd like. Let's go ahead and say I put theta in this bottom angle right here. Now, I need side lengths on this triangle so I can start plugging stuff in. But how do I even do that? Anybody got an idea? Okay. James? Use X? No? Okay. Sir? There you go. Remember, what is sine's ratio? What's its definition? It's the opposite over the hypotenuse. So see, they're giving me a ratio for sine. So we're going to go ahead and say that 5 is the opposite length. Okay, so remember, because I put theta in the base angle, that means the height here, that's the opposite. So we're going to go ahead and say that's 5. Okay, the hypotenuse across from the 90-degree angle, that's going to have a 6. Okay, so now I'm starting to fill in this triangle. That's cool. Okay. It's not a special right triangle, but I still need the third. So what can I do? If I know 2 sides of a right triangle, Pythagorean theorem. What's a Pythagorean theorem? Here we go. A squared plus b squared equals c squared. So let's say this side length that I'm trying to find here, which is going to be the adjacent. Of course, this is the hypotenuse. Let's go ahead and say that it's just A. I mean, you could say B. I mean, it really doesn't matter which leg is A or B. So that would be A squared plus b squared, so that's 5 squared, is equal to c squared, 6 squared. So that's a 25, that's a 36. So if I isolate a squared, what would it equal? 11. 36 minus 25. But I don't want a squared, I want a. So now we're going to take the square root. So this a right here is the square root of 11. Okay. Now I've got everything I need. I can go ahead and find whatever missing trig function I want. Okay. Now you'll notice we're already to the point, it's no longer writing out the ratio for me. But is there anybody who would like me to continue to write that out? Okay, let's do it. So I remember that cosine was going to be the adjacent over the hypotenuse. But what was tangent? What's tangent's ratio? Ooh. Opposite over adjacent. Okay. What's the reciprocal of cosine? Okay, secant. So secant is the hypotenuse over the adjacent. And tangent and cotangent are reciprocals. So cotangent is going to be the adjacent over the opposite. Now, when I first started the problem, I put theta in the bottom angle. But if I had put it at the upper, I'd still be dealing with the same triangle. It's just that the leg values would be switched. Okay. All right. Well, let's go ahead and take a look at 4b. Cosine of theta, I need the adjacent length over the hypotenuse. Okay. Emily, can you help me out with that? Okay. So she said the square root of 11 over 6. Okay. We got a radical, so I have to rationalize, right? What? Okay. Only rationalize if the square root is in the denominator. Okay. It's perfectly fine in the numerator. Okay. So this one here, we're good to go. Okay. So let's try C, 4C. Tangent of theta equals opposite over adjacent. Okay, well, Alex, what would that be? Okay, so the opposite 5 over the adjacent square root of 11. Now this one, we have to do what? We have to rationalize. Okay, so we have to multiply by, again, a version of 1. So this time it's square root of 11. So what would be tangent of theta? Five square root of 11 over 11. There we go. Is there anybody who's having a hard time, who's not seeing how we're getting these? Okay. Yes, sir. Yes. Mm-hmm. Always, because a square and a square and a square root are always inverses of each other. So they just cancel. You're absolutely right. Okay, so take about 30 seconds if you have not already done so. Finish this up, find me 4E and then 4F. Okay, 4E and 4F. Lexi. Yeah. There's a fountain just right outside in the hallway. It works. Oh, no, it's just right there. Yeah, you're good. Yes. You could. So see, at this point, what we talked about on Friday, you could go ahead and fill in just the links that we have here from the definition, the ratio. Or if you know that, cosine and secant are reciprocals, you could just take its reciprocal answer and go ahead and flip it. Okay. Yes. Okay. So wait a minute. So your final answer was 5 or 11 over 11. Yeah. And then you would just rationalize that again. And you'll rationalize that one as well. Yeah. Oh, really? Is it not working anymore? Oh, man, they fixed it. Okay, yeah, you don't want to use that. Uh, I would say just go ahead. Well, I hate for you to use a restroom pass. I don't think they have a water pass on here. I've got a fresh bottle of water in my fridge if you want that. Okay. I mean, unless you're okay just using up one of your bathroom passes today. It's up to you. Nice cold water. There you go. All right. Hey. All right. Oh, thank you. Appreciate that. Okay. Let me go ahead and catch up here. Let's see, who haven't I talked to today? How about Rehan? What'd you get for 4E? Okay. So 6 over the square root of 11. That's correct. But what? We need to rationalize this. Okay. So once I do that, we should be getting 6 root 11 over 11. So that is our final answer. Okay. And let's finish up. Sophia, what'd you get for 4F? There we go. And that's it. Okay. Anybody having a hard time? Anybody lost? Fantastic. Okay. Well, let's move on. Let's go ahead and practice putting these in the calculator. Okay. Now, one thing, I am going to start in a couple of days showing you what a radian is. So your calculator is going to want to either be in degree mode or radian mode, depending on what you're working with. So let me go ahead and show you this. If you'll go to your calculator, okay, go back to your home screen. Okay. This is how you'd go ahead and change it. So from your home screen, go to 5 settings. Now, I'm going to have a lot more listing here just because I have a different software update, than the calculators. But you're going to want to go into document settings. Okay, so number 5, document settings, and then you'll notice your mode here is going to be the second tab. Gradients are also listed there. Don't worry about what a gradient is. It's not a big deal. We're not going to be using them in here. So you'll either switch between radians and degrees. So click degrees. We'll click OK. We're good to go. All right, so just so everybody's on the same page. Well, I showed you the trig button the other day. Where is it? There we go. It's right here on the left side under control, right next to 7. Okay, so if I hit trig, there's all my trig functions. Don't worry about the fact that my calculator is doing that. It has a seizure occasionally. So I believe the first one was cosine of 30 degrees. Okay, so let's go ahead and plug that in. So cosine of 30 degrees. Now let's go ahead and round these to the nearest thousandth. What does that mean? So 3 decimal places. Okay. So I'm going to hit cosine of 30, push enter. There we go. 0.866. That's all there is to it. Okay. So I'm going to come on back over here, and I'm going to say that the ratio is 0.866. Okay. Now I want to try sine of 45 degrees. Okay. Come on over to my calculator. So trig sine 45. Anybody want to help me out? What should I get? 0.707. Perfect. Okay, 0.707. Okay, coming on over here. So 0.707. We'll do a couple more of these. Let's try tangent of 90 degrees. Trig, tangent of 90. What am I going to get? Undefined. So this is our first time that we're going to see that certain trig functions won't exist when I plug in certain angle measures. And there's a specific reason for this. The reason it happens is, one, what's the one thing you can't divide by? You can't divide by 0. So that means that's essentially what we're doing here. If we're going to go at, well, we will, in a couple of weeks, when I start showing you how to graph all 6 of these trig functions, you're going to find that it's not defined, so we have a asymptote there. Just like when you were dealing with exponentials or logarithms or rational functions, you had those asymptotes. Well, trig functions are no different. Okay, they're going to have what you need. So I'm going to come on over here. Let's go ahead and type in undefined. And people always ask me, can we just put the no solution symbol? And I'm okay with that. Okay. Connor, what do you think about that? Okay? Connor's okay. All right. He gives a thumbs up. Let's try one more of these. Sine of 15 degrees. Okay. So, okay. So I'm going to go ahead and choose sine of 15. Okay. 0.259, rounded to the correct spot. Now, this is the one that I want to take a look at very quickly. 0.25. Was it 259? Okay. Make sure I get that right. So the rest of these, 30, 45, those are coming from special right triangles. 90 is going to be starting important to you in the next lesson. But this is the first angle that's just kind of random. So remember, I really, really want you to connect what a trig function is doing when you plug an angle into it. So let's say I have a right triangle, and one of these acute angles is going to be 15 degrees. Okay, remember, what is sine's ratio? It's opposite over the hypotenuse. So the triangle that contains this 15-degree angle, it's taking the length of the opposite side and it's dividing it by whatever the length of the hypotenuse is. And this is the result. So it's not just some random number. Okay, what you're going to get in the calculator, two side lengths have been divided, that's the result. Is everybody okay with that? Okay. Cool, cool, cool. All right. Well, let's go ahead and start looking at some applications here. So number 6, a right triangle with a hypotenuse of 8. Let me go ahead and start to fill this in. So we have a right triangle, a hypotenuse of 8. And I'm a very visual learner. So I like to, if there's not a picture, go ahead and draw one. That kind of helps me, see and make sense of what's happening. And we have an angle that's 36 degrees. Okay, so how about we make that the upper angle this time? So that's going to be 36 degrees. It says find the lengths of the other two sides and the measures of the other two angles. Well, really, it should only be the other angle because if it's a right triangle, you know it has to have a 90-degree angle. So that just kind of seems monotonous to me. All right. Well, let's see here. One thing I want to go ahead and point out, when you're dealing with a right triangle, the two acute angles will always be complementary. Okay, so there's a vocabulary word, super important. What does complementary mean? They add to 90. That's exactly right. So somebody help me out. What's 90 minus 36? So I immediately know this other angle has to be 54 degrees. Now, I didn't have to use that fact. I mean, if we add all three angles, it's going to be 180. So I could have taken 180 minus 90 minus 36. There's a lot of different ways to do this. Okay. But let's go ahead. I can choose to work with either of these two angles that I want. Okay. Let's say because 36 was mentioned, that's my angle of reference. Okay. So what's the base of this triangle? Would it be the adjacent or the opposite? Okay, so the base is the opposite. Okay, we already know that 8 would be the hypotenuse. That means that the height here has to be the adjacent. And let's say that I want to go ahead and find this opposite length of base first. So let's call it x. What you're going to do for this type of problem is you're going to create a basic trig equation. Just a super simple equation that's going to help you figure out the unknown. So if I want to know x, and I know the hypotenuse, I'm going to go from 36. What trig function uses an opposite and a hypotenuse? Sine. So I could write an equation with sine. I could say sine of 36 degrees equals the opposite x that we don't know over the hypotenuse 8. Okay. Now, what you're going to come to find out is you have a lot of freedom in how to solve these. Not everybody's going to solve them the same way. For example, sine's not the only trig function that uses an opposite and a hypotenuse. What else does? Cosecant, it's reciprocal. I could have easily said cosecant of 36 degrees equals the hypotenuse over the opposite. Both of these will give me the exact same answer. If I had chosen to start with 54, this would be my opposite, this would be my adjacent. I could create more equations. Okay, it's all up to you. Now, I personally would say that no matter what equation you create, I like to work with the one where the unknown is in the numerator, because all I have to do is one step, I've got my answer. How do I get rid of that fraction? If you're dealing with a fraction and you want to get rid of it, just multiply through by that denominator. So this is going to be 8 times the sine of 36 degrees is equal to, those 8's are going to cancel, there's your x. Now remember, the other equation will give you the exact same answer, but it's going to have an extra step because x is in the denominator. Okay, let's plug this in. So 8 sine of 36 degrees. Come on over to my calculator. Let's get rid of this. Okay, so document B will wipe out your calculator. So 8 times the sine of 36 degrees, let's say to 1 decimal place. So let's say 4.7. That's the length of our base here. Okay. So about 4.7 units. Okay. Now I'm not quite done though, am I? What do I still need? Yeah, I still need that adjacent length. Okay. So I got to come up with another way to solve this. At this point, I don't even have to use trig anymore if I don't want to. Because I've got two sides of a right triangle, I could use what? Pythagorean theorem. But we're talking about trig, so we want to create a trig equation. Okay. Let's just say I'm going to stick with 36. And let's say the adjacent height here is y. Okay. Now, let's also stick with the hypotenuse. I'm going to talk to you about something in just a second. So let's say I want to go ahead and use 36 to find that height y, also using the hypotenuse. So what trig function uses an adjacent and a hypotenuse? I could say cosine. I could say cosine of 36 degrees is equal to y over 8. Or I could say secant of 36 equals 8 over y. Doesn't matter. And remember, we haven't even touched the 54 yet. I could do my trig functions from those. Okay. So if we do it this way, all I have to do is multiply through by the denominator. So let's see, 8 times the cosine of 36. 8 times the cosine of 36.
That equals 6.472.
So let's say 6.5. Perfect. So the height is about 6.5 units. Okay. Now here's the thing. Okay. We're talking about creating trig equations to go ahead and find the missing side length, right? Okay. Could I have written a trig equation with, say, 4.7? Because we know that length, right? I mean, we just previously found it. So what trig function uses an opposite and an adjacent? Okay, so I could have also said the tangent of 36 degrees is equal to the opposite, 4.7, over the adjacent y. Okay, here's where I want to caution you. Okay, you're trying to get your answers as accurate as possible. The only reason I rounded this 4.7 was because I was putting the answer for that length on the paper. But if I want to go ahead and create an equation that's using that length, you want to make sure to use the exact value from your calculator. Because think about it. We're trying to find this height y. What's going to happen to that value if I already round a value in order to find it? How accurate is this one going to be? It's not going to be as accurate. Sometimes you might get lucky. It might be only a little off. Sometimes it might be a decent ways off, depending on how you round it. So I just want to caution you about that. Okay, how are we doing? Check.
Like what compared to the reciprocal functions over the basic?
Honestly, it doesn't matter. If you prefer the reciprocal, I mean, we never solved that. Does anybody want me to solve the cosecant one? Show you that it's going to get the same answer? Sure? Okay. So let me take this out real quick. So, I mean, it doesn't matter. There's never a time where one is more correct than the other. It just, what would you like to use? So in this case here, I'm still going to start the same way, but in order to get rid of the fraction, I've got to multiply by its denominator, x. Okay. So then this is going to be x times the cosecant of 36 degrees is equal to, the x's cancel, 8. And see, remember, we're trying to isolate the x, so now I have to what? What's the opposite of multiplication? Divide. So when those cancel right there, I've got 8 over the cosecant of 36 degrees. Let's see what happens. So I'm going to come on over here, control divide, 8 over, I need my trig, cosecant of 36 degrees. Oh, see, still gives you the same thing. So there's a lot of different ways you can approach these. Okay. Let's see, how are we doing on time? We're in fourth period. We got it 55. Okay, this is perfect because I only have one more thing to show you. Okay, so there is one problem left on this set of notes, but again, it's just another type of problem that we were looking at a moment ago. So I would encourage you to take a look at it. If you have any questions, definitely let me know. But now, look at this sheet right here. Okay. Because for a lot of what we've been doing today, we've been evaluating a trig function with an angle. We've been getting an answer. Well, now we want to work backwards. Okay. Let's say, and I'm going to emphasize this for a good while, pick any of the 6 trig functions because they're all the same. Doesn't matter. First one I hear. Sine. So the only way to evaluate any trig function is to plug in an angle measure. Now that angle could be in degrees, it could be in radians, doesn't matter. But as we've already seen, when you plug an angle into any trig function, it gives you a specific ratio. For example, sine wants the opposite over the hypotenuse. Yeah. Oh, we're really close to the last part, so I think we got to wait today. Okay. Now, what we're going to do here, we're looking for the angle now. Before, we were given the angle and we were trying to find the ratio. Well, now we're going to reverse this by taking the inverse. You might remember inverses from Algebra 2, Algebra 1, all that good stuff, but basically, here's the idea. There's a lot more to it than this, but I'm kind of oversimplifying. You take all the x's, you take all the y values, and what do you do with them? You switch them. The x values become the y values become the x's. Well, we're going to do the same thing with my 2 quantities here. We're going to switch the angle and the ratio. So when I do that, we're looking at the inverse trig function. And just like before, back in Algebra 2, we're using the same -1 notation to indicate we're talking about an inverse. Okay? So you can only evaluate a trig function with an angle, but you can only evaluate an inverse trig function with a ratio. Okay, well, let's look at this problem. This will be our last one. So we're trying to figure out what theta is. So with respect to theta, what's 12? It's the opposite. Okay. What's 15.7? That's the hypotenuse. Now, I like to go ahead and start out by writing the normal equation. Give me a trig function that uses an opposite and hypotenuse. There are 2. Sine. Doesn't matter if you used cosecant, you're going to get the same answer. So let's say I know that if I take sine of that angle, whatever it is, I'm going to get the ratio of the opposite 12 over the hypotenuse 15.7. Okay. So in order to find the angle theta, I'm going to take those 2 and I'm going to switch them. As soon as I do, this is now the inverse of that trig function. So 12 divided by 15.7 is equal to theta. Okay. How many of your geometry teachers actually took you far enough to show you inverses in there? Because some did, some probably didn't.
No, but we did physics stuff.
Oh, in physics, yes, absolutely. Okay, so let's type this in. Let's see what we got here. So I'm going to go back to my trig button. You'll notice the bottom row, those are your inverses. So we chose sine inverse. What do we have? It was 12 divided by 15.7.
That gives us 39.9.
we go. 49.9. So if I were to round that, what would it be? Because I think it did say round to the nearest whole degree, right? So it'd be 50. There we go. So it'd be 50 degrees. Okay. Does that make sense? Does anybody have any questions on that? Okay. Good, good, good. So hang on to this sheet. Remember, get yourself a binder, a folder, somewhere you can keep these notes safe. Tomorrow we'll come in. We'll finish that up. Okay. Good, good, good. So we got 5 minutes left. Let's go ahead and get those calculators back up to the front. Vanessa, have a great day. Yeah. Okie dokie. So let's stop.